Philip using the sound detector board. So this is the code here. So here at the top, it's just you've just got these three global variables, the constant ints. So you've got the red, the green, and the blue pin for the RGB, and then the sound pin from the board. Then, yep, that's an integer which is sound, and another integer scale. Then here, this is just the serial begin for the printouts. So it's just these three are the RGBs are all outputs. So the red, green, and blue pins are outputs. So then down here, this is the sound equals the analog read sound pin. So that. And then here, this is just the scale. So this number is like the quiet, what's quiet, and then that's the top end loud. And then this is 0 through 3 is how many cases. Then down here, this is just the for the printouts, so it's printing out sound and then the actual like variables that go with it, the sound. And then here, this is just the switch case, so it's switching with scale. So this pretty much if case is 0, then it's blue because the blue pin's on. Then if case is 1, then the red pin's off, the green pin's on, and the blue pin's off, so the red pin is on, so it's going red. And if it is case 2, the red and the green are high whilst the blue is low, so that's yellow. And then down here, it's just the red high, the green low, and the blue low. And then these are all the delays, so it pauses half a second. And then this is at the bottom the default. So if it's none of these, blue, green, and red are all off. So this red wire here is going to 5 volts, which is going here, and it's running across to power the board. And then this ground and this ground, running the RGB, are hooked up right here to this one, which is going to ground. Then this green wire is the signal for the board. And then here are the 300 ohm resistors. And then they're running to 3 signal pins right here, which is 9, 6, and 5. And yep, that's pretty much it. And then here is it running. So if I do this, you can see it's flicking between the colors. Now if I bring up the serial port right here, you can see if I do that same thing, you can see then the cases switch. So here I've added piezo into port 3, and then down here I added piezo is set to 100 Hertz, and then so here we've got blue is on for 0 for case 0, case 1 green's on, then case 2 blue's on, then case 3 red and green's on, and then case 4 blue and red's on, and then finally for case 5 green and blue's on. And then the last one, of course, is just if it's not any of those 6, then it's turned off. The circuit for the complex, so all I did was add a switch so that flips the LEDs on and off. Then here, this potentiometer, if you rotate it, it will increase how loud the piezo is by varying the resistance. So that's simply just hooked up with this yellow wire going to signal pin 3, and the ground, which is right here, going to the piezo. The signal going through the potentiometer to the piezo, and then running to ground. And then the switch is just running to ground through here, and running to ground to here as well. And yep, that's it. Is the complex working? So if I rotate this, you can see it changes colors. And if you turn it down again, there we go. And now if you look at here, you can see if I turn it all the way down, the scale is 0, and if I turn it up slightly, the scale goes to 1. There. And now it is. There we go, now it's 1. Turn it up a bit more, it's 2. Then 3. There we go, there's 3. Then 4, and then all the way up to 5, which is blue and green on.